Here, Libre steel. Okay, so look at these pictures in here. It tells us eye girders, curved, straight. Okay, so that's what we're going to be working with. These are the supported configurations, as you can see in the slide. Okay, seventh edition of ASTO, and we do rating, so we are using the second edition of the ASTO MB software. Okay, manual. So standard roll beam, simple, continuous, so very straightforward, very typical type of bridges, right? Um, what does it provide? Really nice, really nice integration with civil data. So if you have your alignments and profiles, you can actually bring them into Libre Steel, okay, and it's parametric. Definitely, the design checks are wonderful. So I want to show a couple of those things, but not much really today. But the reports are just wonderful, very comprehensive. Okay, everybody was asking when are you guys are going to give us something that we can actually look at the values used for the design check. Right? Guess what? It's there. Load rating, substructure analysis. Okay, this is not just to do the superstructure. Okay, wonderful thing is that now you can analyze the super and then bring the report, the data into the substructure and do that. And for today, guess what? Field splices. Okay. It's a little topic, but let me tell you, it's so important, right? We want to take those field splices. We want to be able to check them. We want to be able to design them. We would like to have those field splices somehow saved in such a format like DGN, so that I can transfer to my drawings. And I'm not going to show you that, okay? I will show you that. Okay, and uh, the last one, interoperability with OpenBridge Modeler. I didn't pour you in that question, but our OpenBridge Modeler, which deals with modeling physical models, okay, of bridges, in this case for the steel bridge, okay, then we'll be able to take that into Libre Steel. So next is some of the little topics that I would like to use simply to tell you. Superstructure, okay? So we are able to model different situations, okay? Especially if you look at the deck and the deck reinforcement and how decks are poured and what do we do with the sequence of construction, all of that is included in the superstructure, okay? We use the standard section libraries for building your cross frames, for example, stiffeners, shear connectors, field splices. So you're going to have a lot of that available to you. And as far as the substructure, okay, as far as the substructure, then we have a library of peers you're very familiar with if you have used in the past LibBridge Concrete or LibBridge Enterprise with different support conditions. Okay, so as soon as we define the structure, it brings in the substructure. You can go back into the dialogues and modify, for example, the shape of the column or the footings themselves, and you can make adjustments. So that's really wonderful. Okay. All right. So, and as far as analysis, yes, as I mentioned before, you get the deck placement sequencing, all the lower cases combinations. We do today the line girder and grillage analysis, and finally the design check. Okay, you have the strength and fatigue constructability checks and so on. Okay, very nice. If this is not something that you are looking for because you want to add your own combination, you are able to do that also. Okay, and reporting. Okay, this is important. Okay, so that we have a detailed, really nice report where it references the LRF, the articles and the equations and articles, etc. Okay, the same thing for summary. For let's say you design and you want to check how well did you do, So there is a report for checking if you are under design or where you are over design, and you make your own adjustments. Okay. Finally, you got there, for example, the camber diagrams that you would like to take to microstation, right? Deck elevations, material quantities, design reports, all kinds of reports that we have. Okay. And finally, to show you here is the detailed reports, right? Look, okay, every question, if you pass the bridge pass that particular check in that particular location, then it will tell you that you pass or you fail. Okay, that type of thing. Okay, field splices. Wow, field splices. Remember, if you use multiple products, well, you don't have to do that anymore. Okay. Um, that's the design check. It includes all law combinations. You see, you can design or you can check individual splice. Or if you have multiple splices, you can, do the same for all at one time. And the most beautiful thing here is also you can save this to design files, DGN files. Okay, and it looks something like this. Okay, and I'm going to show you this part live. Okay, as far as the field of splices is concerned. Okay, how do we locate a splice and how do we interact with our analysis to be able to locate where? Well, basically, as I understand, is you place a field splice in where? In the point of inflection. But if it's in curve, depends on the length, the transportation, you might have to do splices in locations which are not the um, point of contraflexure, right? So anyway, I'm going to show you that live, and you will see dialogues like this, okay, where it has all the information necessary, okay, for the web, the flanges, top or bottom with the corresponding materials, and then you make decisions if you're going to do a check or if you're going to do a design, okay? And finally, here again, these are pictures that I capture from the report that I have taken from Libre Steel, saved the splice to DGM format, where obviously you can look at it an isometric view, but that's not all, okay? We will be able to use dynamic views. So, for example, take the front or a cross section, okay, of the splice, and definitely I can bring this into my DGN sheet files for production, okay, very nicely. Okay, so and then this last question here, okay, I'll leave it for the last. We have time for that, but there are different examples that Libre still comes with. All right, so this is quickly here what I'm going to be doing today. Okay, next.
Raul,
Yeah,
may I interject? We had a couple of
please,
questions here that
please.
I would like to. Someone asked a question: when will the program be updated to the current interim? And we're in the process of putting that in right now, so that will be available later this year. And then there was a second question: can Leapbridge Steel perform column field splice design? And no, this is strictly limited to the steel girders. So we do not consider an axial load in the field splice. Thank you, Raul.
Thank you, Bill. Thank you. Okay, so I am here. So I'm going to show you a couple of files. Okay, one of them is uh, this file right here. Okay, so I'm going to open it. So the model is being read. Okay, at this point, it's on my left-hand screen. Sorry about that. Okay, so as soon as the model is read, this is was previously modeled. But it tells me that the analysis and the design result for this bridge are obsolete. Perhaps who did the model, he did analyze, he didn't save to the results to the Libre Steel itself. He sent it to me. I open it, and this is what I got. So eventually, I had to do the analysis. Okay, and let me show you something else. If I go straight to this field. So I'm going to go over this very quickly, okay? Very quickly on this for the our audience that haven't seen Libre Steel before today. Very quickly. So here is the location for the field splice. So if I go directly to the field splice option, guess what? What I'm going to see is it's going to read the model. It's going to extract the splices that has been previously located. And what does it tell me? That all field splice locations design check is obsolete. Okay, as soon as I click on OK, I will see that the first thing that I will notice in color is that I need to run the analysis. Okay, so believe me, if there are changes to the model, all right, and you have previously analyzed or designed your splices, as soon as you have or somebody have made changes to the model, remember, you will not be lost. Okay, this will tell you, hey, you need to reanalyze me. Period. Okay, you need to check me again. All right, so that is going to happen. So I'm going to cancel here. In using this example, I'm going to show a brief description of how to get there, okay? First of all, we have these different groups of input from the roadway that you are able to select an alignment. You will be able to import geometry, very simple. You click, the sequence is very nice, okay? The sequence is very nice. Look, from roadway to superstructure, substructure, analysis, design, etc., okay? All right, so over here you are able to take your geopack or inroads or civil data from MX and then bring them here and select what you need to leverage during the process of modeling, okay? And here, if you are very familiar, which I think a lot of you are, that's my understanding, is that if you have used LibreX before, you have the same type of input where you define templates, okay? Where in the template you have the different width and the slopes to define the cross slope, and then what else? So I'm going to cancel here. You have the roadway that are able to join for us the roadway information with the profile and horizontal alignments. Okay, so I'm going to cancel that. As far as the superstructure, the sequence is very nice. Okay, so if I go back to the piers, you notice that you can input all the different supports at different locations by station, by distance, with the skew or bearing. Nice, straightforward, right? Nothing really extraordinary, right? Now, as far as the deck is concerned, and here it's really interesting. It is, you notice here the putting sequence 1, 2, 3, 4. If I go there to the number 3, it's highlighted. This putting sequence is going to be utilized later on when we are actually doing the constructability. Okay, so if you have put sequence 1 and put number 2, and then they're hardened, and I go to the 3rd, the 4th, the 5th, all of that is taken into consideration later on. Next, when you deal with, for example, where and how do I do my girders? Do you continue in the downwards direction here in the workflow, candidate, beam, path? Okay. If you have something, for example, that they're not concentric, okay, but you can create your alignment yourself. It's either you can select it from a DGN file, or you put those alignments in Geopack or in inroads, and you can select them later on so that you can define a non-concentric situation. Beautiful, right? It's simple, straightforward. And when you're defining the girders themselves, guess what? Then you have the ability to create as many groups as you want. You can define the continuity by selecting the beginning and end supports, conditions. And in this area right here, very nicely, okay, there is no an arrow, but I know that if I want to select something, click on it and this appears and you select any other references or a direction or an offset. That's how we do it, okay? All right, that's nice. But then we continue. What about if I want to create a cross frame, for example, okay? If I want to create a cross frame, okay, I need to have somehow a predefined section. We don't want to have too many, perhaps. So over here in this area is where you select your sections. Now, where do you do that? Let me back up a little bit here. It's standard sections from the list. You can select from any of the sections that are available. Okay, you can have I girders, you can have T's if you need a T for any reason, but they are here. And then you move them forward, okay? You say, for example, let's say a HP shape, here they are. You select it, you move it by adding, and you see the shape right there, okay? All right, and then finally, here, let's go to the superstructure. You got the cross-frame definitions, as I mentioned before. Where are they located? So they are wizards that allows you to select a different cross-frame. You can have multiple, you can select them. There are wizards that allows you to simply create these different cross-frames along the structure, okay? Next, the stiffener locations, very similar. I like that. I will define a stiffener, okay, by simply selecting the stiffeners. Or after I have defined the stiffener, I can locate the stiffeners along the structure, okay, by simply having this typical through all the dialogues that says add, delete, okay, copy from one member to the other. So there is a lot of functionality for minimizing the pain of developing a model, okay? And one of the things that I didn't mention to you, throughout the entire Library Shield, you notice that there is a save as DGN type of tool here. Anywhere in the product, you click in this particular tool, it will save what you see, okay, into DGM format, and then believe me, you are very creative. You will be able to find a way to utilize this data in a report, in somewhere for sure you will, okay? Now, going back to the field splices, and that's the place where we are going to be concentrated in a few minutes, okay? But substructure, okay? Remember the substructure here. If you have a peer and you click on the peer, look, you can simply go ahead and select the support that you want to work with. And in that support, you are able to simply define the cap, the columns, okay, the footings themselves, okay, multi-column if you want, hammerhead. There is a lot of functionality, and it's very similar to what we did in Lead Bridge Concrete, okay? So the learning for this is very minimum, really, okay? So very minimum. Okay, and over here in this bottom portion is where we do define the loads, okay? So you can see the loads right here, strength, fatigue, and if you have used the product from Combox, you will be able to simply look at the different load conditions that we have. You can simply take and drag to this side, okay, and that's how this works. And then finally, as soon as you have that, the deck placement sequence, that's what I was mentioned before. And here, look, these 5 different pools that we had at the start, now I can actually select and pick, okay? Look, in this case, I selected the 3rd pool, and the last one, I select the 2 and the 4, and finally, all of them, and the bridge is continuous, right? All right, so that's the process. I'm going to cancel here. And if I follow down, there will be an analysis. So you perform the analysis, and after you perform the analysis, you have the design check. You can actually do rating, okay? You can do the substructure design, which is the same thing as RCP, as you are familiar with, okay? Then let's go back. Let's go back to the field splice, okay? We understand this, right? I didn't do it, but I'm going to switch to another file in a moment, okay? So remember, so this is how this works. In this particular splice, for that member number 1, so far what you need to do, if you want to click and add, for example, 1, I'm going to click on member number 2, and I'm going to click on add 1, and where do I place it, okay? Well, I'm going to, similar to the one in the first girder, which is located there. What happens? I have different options from a support, from a cross frame, okay? So if it is from a support, well, you define and select a support number, and then there is an option here that says, let's do there 50 feet from that support, okay, and enter. And then as soon as I do that, this particular location appears, okay? All right, so that's the process that that we need to do. Again, over here you can save to DGN, okay, and I'm going to explain more in detail in the next example, okay? I hope that that gives you a clear of the process really of what we need to do, okay? Actually, I don't need to exit, but let me go back in here. Okay, and I'm going to open a file, and this is the one that I already analyzed, before the presentation, okay? Here, one of the reasons that I of course, it takes some time, that's fine, but the reason that I brought this for us is this. If I go to the analysis, remember, I already pre-analyzed this particular bridge. But what I'm interested in showing you is this. How do I use the product? At least one of the options is to go into my final, okay? You can see the moment diagram already. You definitely will realize where the inflection points are, okay? But I want to simply define one of them, okay? One of the girders. Look, and I can select whatever girder that I want to work with. The important thing is that if this is the place where I'm placing my splice, somewhere in there, okay? That if you want to know about what that distance is, then you click on the measuring tool, you go back in here, and you say, hey, how far I need to go, look. See, it's about 50 feet. That's why I took those 50, because that's what it is, okay? If you are working on a different member, okay, the same thing, look, very quick. You can go back in here. This is what I want, right, in that location. And then move it there. This is 41, you see. Remember, that bridge is not even parallel. There's a skew, okay? But that is the location where that particular inflection point is for that particular girder in that span, okay? So that's how I will use it, okay? Very nicely. Otherwise, you have to go to show the reports, okay? And they show the reports, you will be able to have a very nice view, a diagram that shows the values, etc., etc. All right. So I'm going to close here. I'm going to go back to the field splice. Okay. Now, in the field splice, okay, this is obsolete. Okay, that's okay for me. I need to know. All right. So I'm here. All right. And notice what happened. This is out of date. Okay. I did an analysis, a design. Okay. But before I check this, watch what happens. Okay. Let me go into settings. And then let me make this a little bit bigger here. Okay. So at least we can see what's going on in this the first place that we're going to be working with, which is located on member 1, 50 feet from the support 3. Okay. Here in this lower right-hand side, now you start looking as a splice that was previously defined. It's either by default, but you can see the bolts there. You will be able to, if I zoom in, probably I will be able to look at the place on the top. You see that? Okay, the bolts there. Okay, you can see that. All right. So what happens? There is a column here for design check. Okay, and I'm going to go to settings. Right, so let me go, and there is a default settings in here too, okay? This is the default settings if you want to use, okay? Let me cancel for 1 second, and I go into the settings in this button, okay? And I go over some of the information that you will utilize, and you are very familiar with that because this is very typical terminology, right? One of them is, for example, general data, diameter, or the bolt, material type, okay? Look, so this is a different terminology that you are familiar with. But let's go to the web splice. Okay, look, to the web. So we got distance from the top or splice plate. Okay, all right, look, from the bottom. Okay, you take care of this information. On the next release, when you input something in here and it violates the code because of the geometry, okay, automatically will alert us, okay? For today, in this particular version, it doesn't, but it will, okay? So we have the horizontal edge distance, horizontal crossover distance from one side of the plate to the other side of the plate. We have vertical edge distance, minimum web splice thicknesses, number of bolts for horizontal. Okay, so in here is 2. So that data, including the material, is for the web splice. And now for the flanges, we got top and bottom flanges. Okay, and look at this. This information, again, doesn't need any explanation. Longitudinal end distance. Okay, transverse edge distances. So if I go back to that plate here, then you will see the distance from the to the right side, to the left side, back and ahead and over the splice center line. Okay, so that is the information that you need to define. Okay, and in the bottom here.
Raul, can I
Yes.
interject something on that?
Yes, please.
Okay. On the settings, there's 2 ways the Splice program can be used. If you want to input all of the information and just have the program check it, I think, Raul, you're probably about to talk about that. There's a check at the bottom of the screen. Or you can use the program as a design tool, and in that case, these fields will change a little bit. Some of these values become max and minimums. So I just want to clarify, there's 2 ways you could use this program that way.
Beautiful.
Thank
you. So if you input, thank you, Bill. Thank you so much. So if you input the dimensions, Okay, you can check it. If you have preliminary sizing, it will do the design check, and you still need to go and make the corresponding adjustments. Okay, beautiful, Bill. Thank you so much. So now that this is done, okay, now we can simply remember that it says it's up to date. We're going to check it. All right. So just give it a second, please. Field splice was designed successfully. Guess what? Then, of course, it might tell me not good, right? It might tell me not good, but there is a report that allows me to view the report, right? And that report looks like this, okay? So now that this report is available, okay, first of all, it prints all of the data that was utilized for the splice. That's the echo print, and also will give me, okay, all the different information related to, okay, for example, in this case, top flange splice, length 25 inches, the outer plate, geometry considerations. I see some results nicely that I pass, okay, but you can see here on the left-hand side of the report, there are some information about as far as failing the ratio as per asked, okay? So that is, and look at the report, very comprehensive, right? Look, the demand, the capacity, the ratio, and the references to the articles that were utilized for this particular check. All right, so basically, that is what we can do, right? Straightforward, okay, very nicely, but also saving to DGN, okay, saving to DGN. So please, let's assume that I did save to DGN or automatically, and I'm going to go out of the LibreSteel at this point and show you what we have. Okay, in this case, we work in one splice. Okay, one splice. If I have all of the splices in all the locations, you will see that. But I wanted to share this with you. Okay, first of all, I would like to take advantage of the splice and the 3D model and so on for my plans. So I created a couple of dynamic views. Okay, in this case, I'm going to go to that dynamic view, and I have my cross section. Okay, I can take this dynamic view to my drawing production, right? That's the idea, right? I definitely know many people ask, how can we take this to production, to plans? This is the way to do it. Or if I go back here directly, because I have another dynamic view. Remember that, guys, that I have another dynamic view there. So if I go there, I have this. Okay. In this particular build, you can see that the plate will come there. But if I want to transfer this to my drawings, you know, whatever the slope or the line to the wider plate, I will be able to place a fence, and I will be able to mask this part of the plate for my production. Okay, so that I wanted to show you that because I know that this is something that will minimize our detailing process. Okay, of splice details. Okay, so guys, this is supposed to be informal, okay? And I know there were some questions over there. So at this time, this half an hour went by so quickly. I hope you have lots of questions. Bill is over here. Thank you so much for participating, okay? Not only so, I think we are ready for questions for our great audience that we have today. Okay, thank you so much, Bill. Thank you, and everybody else. Thank you.
Thank you, Raul. And I'd like to remind everyone, if you do have a question, you can please type it into the question and answer box. And we do have a couple questions here. I'll start off with the first one. Does the field splice consider all the load combinations defined by the user? And the answer is yes. It will consider all of the different load combinations for all of the different limit states that you have defined in the steel girder design. Those get transferred over into the field splice design. Okay, and another question here. Do the field splices have to be designed all at, or checked all at once, or, well, actually this module gives you the option of, you can do an individual splice or you can do multiple splices. you can analyze all the splices in the framing all at once. Okay, another question. Could you please show what the design option looks like? So, Raul, you want to
What is that
go
again?
back to
The
the
question?
settings screen?
Oh, okay. To the report.
Go back to the settings.
Oh, to the settings. Okay. So settings. Yes. For the web, the flange splice.
Now change the checkbox there to be design.
Design. Okay. Click on
And
OK.
you will, okay. And let's go back. We'll look at some of the settings. They do change a little bit.
Okay. So we should go back. Okay. Sorry.
That's all right.
Mm-hmm.
Let's take a look at the web splice, for instance. We'll start with that. You'll notice there's the vertical row spacing. There's a minimum and a maximum. And what this does, this enables the user to specify a range. If you don't know exactly how many web bolts are going to be required in the design, you can specify a minimum spacing and a maximum. And then how this will work, we'll start with the minimum number of rows, or columns, I should say. It will start with 2 columns with the maximum spacing, and then we will keep incrementing on the number of bolts until we either reach the minimum, or if it still doesn't work, then we go to a 3rd column, and then we just keep repeating that process. So it's an iterative solution.
Mm-hmm.
But this is an example of that spacing becomes a min and max when you're in design. If you, Raul, flip that to check, and you'll see that there's no longer two input fields. Now you have to specify the exact spacing there. It's 1 field.
Right, right.
So, and there's similar on the flange splice. You don't have to tell it how many bolts are in the flange splice. For instance, if you're doing design, it will compute that. But if you're doing it in check mode, then you do have to tell it exactly how many bolts. Okay, I'll go on to the next question here. Can the program handle steel tub girders and their splices? No, that actually we're in the process right now of implementing finite element analysis into the software, and steel tubs will be part of that. So that's a work in progress. Is the splice design check available for the standard specifications also? Currently, we only have the LRFD specifications. Okay, let's see. Another question. What happens to my field splices if my main girder design, loading, or other physical attribute of the bridge changes? Well, what will happen, if you've already designed it previously, it will change in the, as you see here, it says out of date. So it'll change to say out of date. If everything is in sync between your splice design and your girder design, that'll say current. So that's kind of a graphical way you can quickly spot if everything is in sync or not. Okay, are there any other questions? Okay, here's a question. Can I design one splice and check its applicability at different locations in the same span or on different spans? Currently, each splice is designed individually. We don't really have a copy tool at this point, although that I think would be a great enhancement, where you could perhaps copy a splice from one point to another, and then, of course, the loads would change a bit, but quite often the splices are very similar if you're at very similar locations on the girders, but another question, does Leap Bridge Steel perform an auto field splice design? And the answer there is no, it doesn't automatically design the splices. You would still have to go in and specify the locations and the basic settings. There are default settings, so you don't have to input all of the data from scratch. Well, if you go back to settings, down in the lower left corner there on the screen, there's a use default. You can see, no, I mean the lower left of the settings screen. Right there. Yeah. And then, like you showed over above the OK button, you can apply it that way.
Mm-hmm.
Okay, are there any other questions? Okay, I guess, Natalie, I'll turn it back to you.
Great. Thank you, Bill. Big thank you for that. And Raul, thanks for a great presentation.